In this question, we are given a figure and we are given DB is perpendicular to BC. This is DB is drawn perpendicular to BC. Further, this is D is perpendicular to AB. This is DE, which is drawn perpendicular to AB. And finally, AC is perpendicular to BD. That means this is AC that stands perpendicular on BC. Now, what we need to prove here that this is what we need to prove, that is BE. This is BE, right? BE over DE equals AC over BC. Now, we need to identify the triangle, right? It's one thing is very clear that we are going to prove two triangle similar and then write their corresponding sides proportional. So this is BED, right? So BED is clear from here, and this is ABC. So we are going to prove these two triangles similar, and once they are similar, we can write their corresponding sides as proportional. So check here, we are given this is perpendiculars. Here BD is BD as well as AC, which are perpendicular on the same side BC. So perpendicular drawn on the same base are parallel to each other, or you may use the concept that here co-interior angles are supplementary, considering BC as the transversal. Now we can say that this being parallel to this, BD being parallel to AC, and considering BA as the transversal, we can say that this angle, say 1, is equal to angle 2. Now consider this triangle. The first triangle is DEB and the other triangle as BCA. So now we are going to consider triangle. This is BDE and the other triangle. Here B is this, right? B corresponds to A. So I'll start with the letter A, and D, which is this, and this corresponds to B. So that is B. And here E is 90. Another triangle C is 90 degree. So first we'll be writing angle 1 is equal to angle 2, and they are equal because of alternate interior angles. And the other angle, say if I take angle BD, it's not BD, this is BED, is equal to, and this here is what? ACB is 90 degree. That's each 90 degree. So now we can write these triangles as similar. That is triangle BDE is similar to triangle ABC, and that is from AA similarity criteria. So once the triangles are similar, we can write their corresponding sides as proportional. I'll go for BE first. So BE corresponds to what? AC. So BE over AC is equal to, next if I take DE, and what does DE corresponds to? BC. That is from corresponding sides of similar triangles. Now what you can see that this is not same as our to prove. So we need to swap these two. That's from the alternando, or you may say by cross multiplication. So that is BE. I'm swapping these two. So that is DE over here is equal to AC over BC. And I think this is what we need to prove.